So here we are going to look at SSML. It's a markup language, very much like HTML if you're familiar with it. So the idea here is to give emotions and pauses just like humans. So I'm thinking while I'm talking. So to make the models feel like the way they talk, exactly like humans, we need to give that pause, give some of the fillers, just like we human does. Give some of the emotions, some backgrounds, things like that. That is the idea of SSML. The lip movement, a lot of things are included in SSML. Let's see some of the interesting things about SSML. So this is the documentation of SSML. Like I mentioned, SSML is like HTML for the speech. Basically some kind of styling, intonation, break, emotions, all these things we add into the text file. For example, it is the HTML and the CSS creating this particular header right here so that we can see that header separately from this particular text. Similarly, SSML highlights certain things. It gives that normal human intonation and break and things like that. So go through the document which is mentioned here to understand that particular language. It's like a language. It's a description language. It's a markup language. So what is this markup language describes? It describes how the text to speech to be done, how the text to be converted to the speech. So there is this break, there is this emphasis, all different things are there, emotions are there. You can make it angry, you can make it normal, whispering, all kind of different things you can do when it convert to the speech. This is very useful if you're creating an audio book or something of a novel or something like that. So you need to put emotions like a mono act. So it is a kind of language of its own. There are so many examples they have given. We'll see a couple of examples. For example, this is the kind of normal one, and there are different types of breaks and things like that. Weak, medium, strong, extra strong, very similar to the size font in the HTML. It's all in milliseconds. So we'll see an example like this with the different breaks and things like that. You need to listen carefully. I don't know how much it will come in this mic, but we'll try our best. But try these things yourself to understand the difference, and something says very subtle difference. Some of the things even I'm not able to make any difference, but I think there is difference. So play around it. I'll show you a couple of examples and you can experiment along with it. And this page, you can search for SSML document, structure and events in Azure AI Service Speech Service. That's what we are looking here. So let's go to the code. This is a code for SSML. Again, same speech synthesizer, speech config and the audio config. All that stuff remains the same, no difference. One of the things we are doing here is opening up a file from our local directory. Right here, we are opening a file. What is a file? It is an XML file. If you are not familiar with XML, it's just like JSON. In fact, XML is kind of the father of JSON, YAML, and all kind of formats. So we'll see that file, the XML file, and we are playing it here using the XML file we have opened here. Just single line of code again. There's a lot of things based on this particular file. Now let's have a look at the file to understand more about it. So we have around 8 files. I'll show you a couple of them, probably not all of them, but you can play all of them if you want. This is the one we have seen in that SDK sample in the documentation. And this is another one with 2 voices. There are 2 different voices. One is this, and this is Ava and Andrew. So there are 2 different voices. It's like an interview, 2 people talking to each other. It'll sound like that. Feel free to add more stuff into it. So 1 and 2 we will look. So here there is an additional effect. It's not very clear, at least in the audio, but there is a subtle difference. Style angry, style degree 2. So there are different styles, just like the HTML, if you know what I mean. If you're familiar with HTML, it's all about styles and decorations. Probably depends on the style degree. Things may change. I have not experimented much with this, but feel free to do it. Sometimes it can be fun. So there is this emphasis thingy on the meetings. So level moderate. So there is a moderate emphasis on this particular word. Then sixth one, we have break. So we are going to see break between different types of breaks, medium, then this almost 1 second break. So it may sound similar to you, but slightly different. This is type sentence boundary, value 1000 millisecond. So there is a sentence boundary in the end with 1000 millisecond. We'll see that. So this is like a facial expression, and we are mentioning this particular sentence. So one thing common with all this text-to-speech scenario is that they are very human-like, as far as I can say. Hardly any difference between a model speaking and actual human being. So first is the simplest one. I'm going to execute that in the code. So this is the example for it. So I'm going to keep it 1 so that we will execute the 1 here, the first one. So let's see that. So this is the one we are going to execute. It's the one we are going to play. I have no breakpoint, as this is the code which is doing actual stuff. Otherwise it is the line number 11 in the Python. So start debugging. I don't know how much you will be able to hear.
This is the text that is spoken.
So it was just a normal text to speech. I didn't see any difference, at least. Now let's go for the second one. In that there are 2 voices, Ava and Andrew. So I'm going to make this 2.
Good morning.
Good morning to you too, Ava.
So that is pretty human-like, as if someone is responding to this particular text. There is an excitement in the second voice. Not sure how they have generated it, but exactly like human response. You can play it yourself, have a feel about it. Now we are going for the third one. Let's see the SSML for the third one. EQ car, that is the effect. This is the text, again same text we are speaking, no difference. The third one. Start debugging.
This is the text that is spoken.
As a matter of fact, I didn't find much difference. It looks very similar to me. Probably if we change some of this effect setting, we may find some difference. Third one looks very similar to me as the normal one. Let's try the fourth one. So this is the fourth one, and it is like, do I sound angry to you? Let's see if it sounds angry to us. Again, when you run it, make sure that the Python is selected. The XML file doesn't run.
This is the text that is spoken. Do I sound angry to you?
It doesn't sound much angry to me, to be honest. Although it is supposed to sound angry. Probably I may have to fiddle with it more. But right now, I'm not finding it angry. By the way, one of the things I have not explained is the XML. If you're seeing the XML for the first time, or the HTML for the first time, it is exactly like JSON. So this is a key, and these are different values. Not exactly same, but similar, I would say. So nested structure. So the speak has this much attributes, version, this XML things, and the XML language and things like that. Then voice has this attributes, and inside voice we have this whole thing. Very similar to JSON. In fact, you can convert this exact same thing to JSON and understand if you want. But XML is another representation of data, more or less row and column. That's all about XML. So this is the ending tag. This is where the tag ends. All the tags, the starting should end. The parsing of the XML was very cumbersome because of the tagging and ending and things like that. It was very compute intensive. That's why we have come up with a JSON and all kind of other formats like YAML and things like that. XML is not very popular here, but I have seen a lot of XML things in Microsoft things. For example, SSML in this case. Could it have been JSON or YAML? Absolutely yes. But I'm pretty sure there is some C# library sitting somewhere inside the Microsoft code base which reads this thing, because originally XML was pushed by .NET. Enough history about XML, but if you want to know more about XML, you can search about it. But otherwise, it's just JSON or YAML or anything which has a dictionary structure, dictionary and arrays. That's all about it. Now, coming back, we are going to try the fifth one. So that's the fifth one. Let's see what's the fifth one. So there is an emphasis in meetings. Let's see if that is audible, that emphasis.
I can help you join your meetings fast.
Yeah, definitely there was some kind of emphasis I found. So it is definitely working. I'm pretty sure there are ways to give more emphasis by changing the parameters of the whole thing. So level in this case, you can change the level and see. But in this case, I found there was a level of emphasis on the word meaning. So that worked as expected. Now let's go for the sixth one. In the sixth one, there is break. So it is the same text, but there are breaks, different types of breaks. Let's play it and see. So you need to make it 6 here. We have total 8. You can have more.
Welcome to text-to-speech. Welcome to text-to-speech. Welcome to text-to-speech.
Yes, there was a delay and the delay was increasing order. So I think that worked exactly as it is. Very accurate. The delay was correct, or the break was correct. It is not a delay, it is a break. There is a lot of difference between all these things. It's giving a natural break. If you play with it, you will understand. This is some kind of sentence boundary like we discussed. And the sentence boundary is 1000 millisecond. So let's see how it's going to be there. Again, I'm going to put it 7. Going to play.
If we're homeschooling, the best we can do is roll with what each day brings and try to have fun along the way. A good place to start is by trying out the slew of educational apps that are helping children stay happy and smash their schooling at the same time.
Yeah, that delay was exactly as it is. In the end of the sentence, it had a pause and then it started. That was very good, very human-like speech. So feel free to experiment around this SSML. And finally, this is again the documentation. So there could be more things can be done. Some of the styles we have used, we may have to increase the power of that particular style to understand how the style looks. Probably we need to change it. Couple of things was very good was the pause after the sentence and the interview kind of thing we saw between two people. Definitely it looked like two people talking. Very natural sounding examples. There are more examples and things like that. Phonetic alphabet to get the pronunciation right. I have not tried any of it, but there are so much details to it. I can see there is enormous amount of effort has put it into these models. So feel free to experiment if you know some of these languages, try some of these things, but otherwise this is SSML. So we have seen SSML as a very useful way to change the way AI generates speech. We can create different voices, the intonation, the pulse, emotions, just like human, it is imitating. In fact, the files we have seen, the XML files, the SSML file, can be auto-generated by the AI itself, which means AI can generate its own emotions. For example, the voice assistant in GPT-4o, the OpenAI model, is an example. It creates SSML by default, and it acts like a normal human with emotions. So that is possible, and that's how AI is gonna behave in the future. They generate SSML and talk exactly like humans.